Hello everyone, how are you? I think you might be enjoying our lectures. Now, your today's lecture is on one of the thermal properties of solids, that is thermal expansion. Whenever heat is provided, almost all the solids, liquids and gases, they expand. So we are going to study the different types of expansions which are going to take place in solids. Now, why actually the expansion takes place? You know, in solids, all the atoms, they are interlinked to each other with interatomic forces, which are regular continuous vibrations. Whenever heat is provided to them, these vibrations, they become more fierce and their dimensions changes. This causes three types of expansions. One, linear expansion. Number two, superficial expansion. And number three, cubical expansion. As the name of all these three types of expansion suggests us that in linear expansion, any one of the dimensions that we are going to consider here as length of solid body changes. In case of superficial expansion, two dimensions, and so the surface area of that body changes. And in case of cubical expansion, there is a three-dimensional change in the body, and you are going to experience a volumetric change. Volume of body changes. Now, we have already studied about why these expansions are taking place, because whenever the heat is provided, the vibrations of the interatomic particles that increases, that causes the change in the dimensions of the body. Now, let's have the value of the coefficients for these different three types of expansion. Now, firstly, we are going to have the coefficient of linear expansion. When heat is provided to a body, if let's suppose we are having a body of length, its original length is L, it is provided heat, the body is heated. Due to the change in its interatomic distances, this body is going to acquire a new length, which is now more than the previous one, and its new length is going to be L dash. So the change in length of body will be L dash minus L. If this change in body, this change in length has been there due to the change in temperature by a very small difference, change in temperature is delta T, which is T2 minus T1. T2 and T1, they are the two temperatures of the same body at two different instants. Now, look at this. Your change in length. So, it is experienced that this change in length L dash minus L, that depends directly on its original length, that was L, and the change in its temperature, delta T. So, we can write down the change in length L dash minus L, that is proportional to L delta T, or that can be written as alpha L delta T. Here, your alpha is the coefficient of proportionality, and here, in this case, it is known as coefficient of linear expansion. So with the help of this expression, which is going to be now L dash minus L is equal to alpha L delta T, you can find the value of the new expanded increased length L dash. L is the value of the coefficient of linear expansion alpha. From here we can get the value of L dash is equal to L plus alpha L delta T, or you can write down L can be taken common over here, 1 plus alpha delta T. This is one of the expression which is going to give you the value for the increased length, means the new value, new expanded length. It is dependent on the value of the original length which was there, then the value of the linear expansion, which is now going to be dependent on the type of material of the body, and the increase in the temperature of the body. Or from here also you can get the value of alpha. It can be L dash minus L upon L delta T. That is dependent upon the difference delta L upon L delta T. This is the expression for the value of coefficient of linear expansion. Now we can again go through this. Change in length, that is directly proportional to the length, original length of the body. That is dependent upon the difference of the temperature which is provided to the body. So from here we got the value of L dash, which is the increased value of the length after the expansion, and the value of coefficient of linear expansion. In the similar way, we can get the values of coefficients of superficial expansion, here. Let's see the coefficient of superficial expansion. That is given here as beta. As we have got here the value of alpha, here we have got the value of alpha, that was what? That was equal to L dash minus L upon L into delta T. In the similar way, beta, the coefficient of superficial expansion, that is going to be S dash minus S upon S delta T. S dash, it is the original value, new value, that after expansion, it is the value of surface area after expansion. S, it is the original value of that surface area before providing it the heat, and delta T is the difference in the temperature. Similarly, the coefficient of cubical expansion, that is represented by gamma, and that is equal to the difference upon the volumes, the newly or expanded volume, the original volume V, and the difference in temperature delta T. These are the three coefficients of the thermal expansion, and they are related to each other as this one. This is the ultimate relation between these three expansions, alpha, beta, and gamma. Now, you can ask your questions. You can even give me your feedback, whether it is positive and negative. You can also follow me on my YouTube channel, Physics Classes by Dr. Dushyant Pradeep. Have a nice time ahead during our different lectures. Please follow and subscribe. Have a nice time and great time ahead. Thank you.